Chapter 24, Part 1, we are going to talk about creating confidence intervals for two samples. So when the conditions are met, which we'll talk about in just a minute, we can find a confidence interval for the difference between the means of two independent groups. So just like we saw with proportions, we're going to look at two separate groups and find a confidence interval for the difference between their means or their averages. So what we're going to do is start with finding the difference in the sample means. So I'm going to take x bar 1, that'll be the mean from my first group, and subtract x bar 2, which is the mean of your second sample. We'll add and subtract our t-score with degrees of freedom, and then we're going to multiply by the standard deviation. Now the standard deviation does look significantly different now that we're looking at two groups. The standard deviation for this is a big square root. We're going to take our standard deviation from our first sample, so S1, we're going to square it and divide by the first sample. We'll do the same thing for the second group. So the standard deviation of our second group squared divided by our second sample. Just like we've seen with our other confidence intervals, we do want to make sure that we check conditions. The first condition is the same. Both of these groups must be random. So we need to make sure that both of our samples are random. The second is, again, that 10% condition. So we need to make sure that both samples are less than 10% of our population. Okay, the third condition, we've been checking to make sure that our distribution is nearly normal. Again, this is true for the third condition, but we need to check it for both samples. So again, we need to make sure that both samples are nearly normal. So we're going to create those histograms and normal probability plots again to check this condition. We'll just kind of have double the work here because we will need to check it for both samples. Okay, the fourth condition, and this is a very, very important one, we need to make sure that the samples are independent. When you're checking this fourth condition, just make sure that it is impossible for a subject or a participant to be in both groups. You cannot be both a man and a woman at the same time, so those would definitely be independent groups. Okay, let's go ahead and look at an example. Example 1 says resting pulse rates for a random sample of 26 smokers had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among 32 randomly chosen non-smokers, the mean and standard deviation were 74 and 6 beats per minute. Both sets of data were roughly symmetric and had no outliers. We want to create and interpret a 95% confidence interval for the difference between smokers and non-smokers. So hopefully you can tell just by reading through it that we are looking at two samples here. We have smokers and we have non-smokers. I can also tell by my prompt, it says that I want to create a confidence interval for the difference. So that's telling me that I should be looking at two samples here. Okay, I'm going to start with writing out all of my variables. So I know I have two groups. I have smokers and I have non-smokers. In each of these groups, we should be able to find the sample mean and the sample standard deviation and the sample size. So let's look at smokers first. So there was a random sample of 26, so that means our N1 is 26. They had a mean of 80, so I'm going to write that as x bar 1 is 80. And standard deviation of 5, so S1 is 5. Non-smokers is my second group, so I'm going to list these the same, just as 2. So my sample size for non-smokers was 32. X bar 2, so the mean of those non-smokers was 74, and standard deviation was 6. You could skip that part, but I do think it's nice to write out the variables before we get started. From here, I'm going to check my conditions. Make sure we're always checking conditions before we start actually creating the confidence interval. So my first condition is that both samples are random. I see that they took randomly chosen or randomly sampled people there. So I'm going to say both samples are random. The second condition, checking to make sure that my samples are less than 10% of the population. I definitely think that 26 smokers and 32 non-smokers are less than 10% of all smokers and non-smokers. Third condition is making sure that both of our samples are normal. Now they didn't give me the data here, so I cannot make a histogram or a normal probability plot, but they do give me some information about what these distributions look like. They're telling me that both sets of data were roughly symmetric and had no outliers. So I'm assuming here that with that roughly symmetric and no outliers is telling me that they should be nearly normal. So I'm going to say both samples are symmetric with no outliers. So they should be normal. Okay, the fourth condition, I need to make sure that the two groups are independent. So I'm definitely thinking they are independent. I cannot be both a smoker and a non-smoker. It's either one or the other. So these samples are independent. Okay, once my conditions are met, I can go ahead and start working on creating my confidence interval. So I'm just going to start with rewriting my formula here. I have x bar 1 minus x bar 2 plus or minus a t-score times the square root s1 squared over n1 plus s2 squared over n2. Now, looking at the data that we started out with writing, our summary stats here, it looks like we have both of the x bars, we have both of our standard deviations, and we have both of our n's. The only thing that we're missing is that t. We do not have our t. Now, typically with one sample confidence intervals for means, we could easily find this degrees of freedom, and once we had our degrees of freedom, it was quite easy to find the t-score. What's tricky is now that I have two samples, right? One sample was 26 and the other was 32. Which value do I use to find our degrees of freedom? So the AP graders are okay if we use our calculator to find the degrees of freedom. So we're going to use that calculator to find our degrees of freedom. Once we have those degrees of freedom, we can then use that to find our t-score. So I'm going to go to my calculator here. I'm going to go to Stat, Tests, and I am looking for a 2-sample t-interval. So So I see a 2 sample t-test. Looks like here we go. 2 sample t-interval. So what I'm looking for should be 0 on your calculator. Okay, again, it's going to give you the option for data or stats. We were given stats here, so I'm going to go ahead and type in all of my values. My x bar 1 was 80. My standard deviation is 5. Notice they're saying SX1. Again, that just means standard deviation. N1, 26. X bar 2 is 74. Standard deviation of 6. N32. Confidence level this time is 95. You will see on this interval it's asking for pooled, yes or no. We pooled for our proportions, but we will never pool for means. We are never, ever, ever going to pool for means, so always keep that as no. You would only pool if you believed that your standard deviations were the same. We clearly can tell that they are not the same. We'll never, ever pool in AP Stats. Okay, I'm going to hit calculate. And it gives me my interval, which is nice, so I'll be able to use that to kind of check my work here. But it also gives me degrees of freedom. It's giving me 55.95. Okay, from there I can use this degrees of freedom to find my t-score. I kind of ran out of room, so I'm going to jump down to the bottom of my page here and find that t-score. So my degrees of freedom right now is 55.95. I'm going to round that, so 56 is probably the closest. I can't have a degrees of freedom with a decimal because your degrees of freedom was always one less than your sample size. It's impossible to have a decimal there. So once I know my degrees of freedom, I can quickly draw my little picture here to find my t-score. I'm looking for a 95% confidence interval. So that means on this left-hand side, I should be left with 2.5%. So second vars, my inverse t, an area of 0.025, degrees of freedom of 56. Gives me a t-score of negative 2.00. Okay, so again, every time that we're doing a confidence interval for these two means, you will have to use your calculator to find those degrees of freedom. Once you have the degrees of freedom, you can use it to find your t-score using inverse t. Now that I have the t-score and I have all of these other statistics, I can go ahead and start plugging things in. So I'm going to plug in my sample means, so 80 minus 74, plus or minus that t-score we just found, 2.00. I'm just going to write it as 2, and I'm going to make it positive because that plus or minus accounts for the negative. Opening my square root, I'm squaring my first standard deviation, so 5 squared over 26, plus the second standard deviation squared, so 6 squared over that sample size of 32. $80 minus 74 is going to give me 6. Again, I like to plug in that margin of error, figure out how far off we are. Get 2.88. I'm just going to round that to 9. So I'm subtracting that. And adding to give me my interval. Once we have our interval, we do want to write our interpretation, and we are going to start this in this, we're going to basically do this the same way that we did for confidence intervals for two proportions. So I'm going to start off the same way, saying that I'm 95% confident that the true, now notice we're not looking at proportions anymore, we're looking at means or averages. So I'm going to say the true average, and all of our data was looking at resting pulse rates. So I'm going to say the true average pulse rate for, here's where we're going to insert the first group. So that was looking at smokers. So the true average pulse rate for smokers is between my interval. So I'm going to say 3.111. And the unit for this is, if I look back at my problem, we were looking at beats per minute. So I'm going to do 3.11 beats per minute and 8.889 beats per minute. Both values were positive, so we are pretty sure that that average pulse rate for smokers is between 3.11 beats per minute and 8.8889 beats per minute, higher than the average pulse rate for non-smokers. Hopefully that is sounding familiar. Generally, it's following the same format as we saw with proportions. The only difference is that you are looking at averages instead of proportions. When you go to write this conclusion, if you had one that was negative and one that was positive, you would say we're 95% confident that the average pulse rate for smokers is maybe 3.11 beats per minute lower and 8.889 beats per minute higher than your non-smokers. So it's possible that you have higher and lower, again, depending on whether or not both of them are positive, both of them are negative, or one positive, one negative. Okay, let's go ahead and look at one more example. All right, example 2 says, here are the saturated fat content in grams for several pizzas sold by two national chains. We want to create and interpret a 90% confidence interval for the difference in fat content between the two chains. So it looks like we're looking at brand D and brand PJ. Hopefully you noticed the big difference in this problem is they gave us the raw data. They're just giving us the grams of fat for each pizza instead of just giving us the average and the standard deviation. Okay, let's go ahead and start with plugging this stuff into our calculator. So I'm going to go to my stat edit. And in my L1, I'm going to type in all of brand D. So I'm going to put brand D in L1, brand PJ I'm going to put in L2. I'm going to go ahead and pause my video while I type these in. Once you're done typing them in, go ahead and play the video again. All right, once we have these all typed in, we can use our calculator to find the means and standard deviations. Since I have brand D in L1, when I find this average, I'm going to call it X bar 1. I'll also find S1 and N1. Okay, to do this, we're going to press Stat, go over to Calculate, doing one of our stats, and we're going to start with finding it for the data in L1, so I'm going to leave that as L1, go down to Calculate. It gives me an average of 11.25, standard deviation 3.19, N is 20. Okay, we'll go ahead and do the same thing for our second sample. The only thing that we have to change is when we go to our calculate one variable stats, make sure that this list is now pulling from L2. So I'm going to second 2. This gives me an average for my second group of 6.53. S2 is 2.59 and N2 is 15. You can round a little bit differently if you wanted to here. I decided to do 2 after the decimal since that was what my first average gave me. Okay, from here I can now try and check my conditions. Okay, the first condition is that random condition. It doesn't say that this data was random pizzas. It's just, whatever, I don't know how they got this data. It doesn't say random, but I do think that the 20 pizzas and 15 pizzas should represent all pizzas from these 2 national chains. So I'm going to say 20 pizzas from brand D and 15 from brand PJ should represent all pizzas from these brands. Okay, next one, 10% condition. I definitely think that 20 pizzas and 15 pizzas is less than 10% of all pizzas from these brands. Third condition, I need to make sure that this is nearly normal. So I'm going to create a histogram and a normal probability plot for both data sets. So in my calculator, I'm going to go to my stat plot, so second y equals, I'm making sure that it's on. I'm going to start with a histogram, and I'm going to be pulling data from L1. So I'm going to start with brand D here. I'm going to go ahead and sketch this real quick. Again, doesn't have to be pretty, just has to be a quick sketch. Looking pretty normal to me, and this top bar is quite large, and then on the side is kind of trickling out. But let's go ahead and make a normal probability plot just to check. So I'm going back to my stat plot, second y equals, changing it to this last option. Definitely looks pretty straight there. So I'm going to say brand D is nearly normal. Okay, we're going to do the same thing for PJ. So I'm going to my second y equals. The only difference this time is that you want to make sure you're pulling data from L2. That's where our PJ data is. So I'm going to go to second L2, zoom 9. Ooh, that one is not looking very normal. Okay, again, we're going to go ahead and make the normal probability plot as well. I'm leaving that as L2. Okay, although my histogram looks kind of weird and not normal, this is definitely pretty straight. So I'm okay to say that brand PJ is also nearly normal. Oh my gosh. Okay, my fourth condition. Do we think these two groups are independent? Can a pizza be from both brand D and brand PJ? I don't think so. So these samples are independent. I'm assuming that D stands for Domino's and PJ, Papa John's. I can't order pizza from both at the same time. It's either one or the other, so we are definitely good with our independence here. Whew, okay, conditions are checked. So the next thing I'm going to do is use my calculator to find those degrees of freedom. Okay, in our calculator, we're going to run this test. So I'm going to stat tests. Again, I'm looking for a 2-sample t interval. This time I have the actual data, so I'm going to highlight data there. You can make sure you have data typed in L1, L2. Again, your frequencies should just be 1. Those are probabilities. We don't have any probabilities. This time we want a 90% confidence interval. Still no pooling, so I'm going to calculate. Gives me degrees of freedom of 32.75. So rounding would give me 33. Once I have those degrees of freedom, I can draw my little picture to find my t-score. I'm looking for the middle 90%, which means there's 5% left on the end. So we're going to go ahead and use inverse t to find a t-score with degrees of freedom of 32. So second vars, inverse t, 0.05 is my area, degrees of freedom 33. We get negative 1.69, or you could use it positive 1.69. From there, I can start plugging into my formula. I'm just going to write that formula one more time. Okay, taking all of my values and plugging them in. So I have 11.25 minus 6.53 plus or minus the t-score we just found, 1.69, square root, my first standard deviation squared over 20, plus my second standard deviation squared over 15. Okay, go ahead and start calculating. Okay, sometimes once I have that interval, I do like to run that test again, just to make sure. So I'm at my 2-sample t interval. .06, which is pretty darn close. 6.3719, again, pretty close. All right, almost there, guys. Last step is writing this interpretation. So we're starting with our confidence. I'm 90% confident that the true average, what were we looking at here? We were looking at fat content. So I'm going to say the true average fat content for my first group was brand D. So I'm going to say for brand D pizzas is between both intervals, both parts of my interval are positive. So again, I'm going to say between these two amounts higher. Make sure you have your unit, which this one is grams. So I'm going to say between 3.07 grams and 6.37 grams higher than the average fat content for brand PJ. So if this Friday night you're hanging out with your friends, somebody says they want Domino's, somebody else says they want Papa John's, you can just quickly whip up this little confidence interval and you can say, I'm 90% confident that the true average fat content for Domino's is going to be between 3.07 grams and 6 grams higher than the fat content in Papa John's. So if I'm trying to, watch my fat intake, I think we should order Papa John's because there's going to be less fat than Domino's. Hey, this is a pretty long problem. There's a lot going on here. I think the biggest difference from the ones that we've seen in the past is this idea of using your calculator to find your degrees of freedom. You will get used to that. We're going to have to use our calculator for degrees of freedom anytime that we have those two samples.